Vectors. Vectors have magnitude and direction. It is denoted by a arrow which have tail and head. Physical quantity are two types: vector quantity and scalar quantity. Vector quantity like velocity, force, current, displacement, acceleration, and scalar quantity like length, volume, mass, etc. Scalar quantity have only magnitude and no direction. Vector quantity have both magnitude and direction, and its value can be positive or negative. Vector quantity obeys vector law of addition, and current is also a vector quantity as its direction can see that opposite to the direction of flow of electrons. So current is a vector quantity. If we talk about notion of a vector quantity is denoted by a small arrow above the physical quantity. Vector quantity, it should be written as a vector. This arrow represents the vector quantity. The direction of the vector quantity, example displacement, is expressed as s vector. This arrow represents the direction of its magnitude, means this is a vector quantity. Magnitude of vector notation. If vector quantity is a vector, then magnitude of vector is written as a vector is equal to a or a vector modulus. Example, magnitude of vector displacement is written as s. Magnitude of s vector is equal to s, like v vector, magnitude of v vector is equal to v. Representation of vector, factorial and equation by an arrow. So this arrow represents a vector quantity and its magnitude is a modulus of that vector, and by an equation with some standard terms, a vector is equal to here magnitude of that vector, and it is a unit vector. This represents the direction of a vector, and magnitude is equal to square root of p square plus q square. You will get more information further as we proceed. Factorial representation. So this is a vector having a theta with horizontal axis, and this is a tail. Length of a vector represents magnitude, arrowhead represents direction with the help of an angle with horizontal or vertical. So this arrow have no applications, no much applications in your syllabus, but I'm giving you some information about vectors, so need not to be worried. Equation form. Displacement of vector as a combination of s contribution of y contribution. So let's not consider it. Unit vector. So this is a very important topic. Unit vector, you should know about unit vector. A unit vector represents the direction of a given vector. So if we want to define a vector, we need to do things: magnitude and direction. So this is a way how we write any vector. This is an acceleration vector. It is denoted by its magnitude, which is modulus of a vector, and its direction a cap. This is a cap where a vector is a vector. This is a magnitude of vector, and this is a direction of a vector or unit vector. A unit vector is nothing but given vector upon magnitude of that vector. Unit vector or direction, this is a unit vector. When we transpose the previous thing, you will get the vector upon magnitude of that vector is equal to unit vector. So it have a great applications in your questions, so always keep it in your mind. Representation of vector by unit vector. So this is a force, means this is a magnitude of this is a simple vector, and it is a unit 10 Newton in east direction. Now so this is a only example. Now divide vector f by its magnitude. F vector is equal to 10 Newton in east upon 10 Newton. This is a vector by divided by its magnitude. You will get a unit vector 1 Newton in east. So this is a unit vector. So you have been understand that how we use unit vector. Now how to represent vector along three directions. So let's make a coordinate system where this is a y-axis, this is a x-axis, and this is a z-axis. Here unit vector along the x-axis is I cap, unit vector along the z-axis unit vector along the y-axis is z cap, and unit vector along the z-axis is k cap. Means I cap, j cap, and k cap are the unit vectors along the x, y, and z axis respectively. Here you can see I have written I cap is represents unit vector along x-axis, j cap represent unit vector along y-axis, k cap represent unit vector along z-axis. So this table also tells you about the coordinate system. That means I vector represent along positive direction plus x-axis, negative direction minus x-axis, j cap plus y-axis minus y-axis, and k cap plus z-axis and minus z-axis. So this is for along positive direction and along negative direction. Force vector. This is an example. So force vector is equal to 10 Newton along positive x-axis. So we can write it F vector is equal to 10 Newton I cap. Force, second example, force vector 10 Newton along negative x-axis. So we can write it force vector 10 Newton minus I cap is equal to minus 10 Newton I cap. Force vector is equal to 20 Newton along negative z-axis. So we can write it F vector is equal to 20 Newton minus k cap is equal to 20 Newton minus 20 Newton k cap. Now types of vectors. Equal vector. So we should know how to deal with vector. So here you will find the way. Types of vector. Equal vector, two vectors having equal magnitude as well as direction. These are the two vectors, a vector and b vector. These two vectors have equal magnitude, and as in both are parallel to each other, so they have the same direction. So these two vectors are equal. You can represent it by writing this type: a vector and b vector are equal vector if theta is equal to 0 degree or parallel vector. So a vector, magnitude of a vector is equal to magnitude of b vector, and direction of a vector is equal to direction of b vector. So these are equal to each other. Now opposite vector or negative or anti-parallel vector, two vectors having equal magnitude but in opposite direction. These are two anti-parallel vector, a vector and b vector. A vector is not equal to b vector. A and b are opposite vector if theta is equal to 180 degree, means these two vectors are anti-parallel to each other. Now magnitude of a vector is equal to magnitude of v vector, but direction is unequal. That means negative to each other. So here we use a minus sign to represent the direction. That means we know these two directions are opposite to each other by considering this negative side. Now remind one thing, that in anti-parallel vector or opposite vector, always magnitude remains same. Zero vector, a vector having zero magnitude and undefined direction. Zero vector is represented by zero vector. This is a f vector, this is a minus f vector. Both have same magnitude and but opposite direction. These two vectors cancel each other. So this is a zero vector due to the cancellation of these two equal vectors which are opposite in direction. Here the property is a vector plus minus a vector is equal to 0 vector, a vector minus a vector is equal to 0 vector, a vector into 0 is equal to 0 vector. Property a plus 0, a minus 0, a. This is a scalar quantity g multiplied by 0 vector is equal to 0 vector. Here lambda is a scalar. Now how is vector calculation performed? Vector addition is performed by triangle law, parallelogram law, polygon law. For two vectors we use triangle law. For two vectors we use parallel law. For two or more than two vectors we use polygon law. Here the most important law is parallelogram law. What you should know about the triangle law or polygon law. So first law is triangle law of vector addition. This is the first method to perform the vector addition. According to it, if two vectors to be added are arranged in form of two sides of triangle taken in same order, then their resultant is given both in magnitude and direction by third side of triangle taken in reverse order. If this is a vector and this is a v vector, these are two different vectors, then a vector is added to b vector and their resultant is a plus v vector. So here you know that these two vectors are in the same direction, but this have a coinciding head. So